Today we are going to learn about mastering PCA with Scikit-learn, a practical guide. We'll explore how to implement PCA for dimensionality reduction, enhance model performance, and improve interpretability using Scikit-learn. Welcome! In this video, we will delve into principal component analysis, or PCA. PCA is a powerful statistical technique used to simplify complex datasets by transforming them into a set of linearly uncorrelated variables known as principal components. This transformation is crucial in data science as it helps in reducing dimensionality, thus making datasets easier to explore and visualize without losing critical information. By the end of this video, you will understand how PCA can enhance model performance and interpretability, making it an indispensable tool in the toolkit of any data scientist or machine learning practitioner. Before we dive into PCA, let's make sure your Scikit-learn environment is set up correctly. First, you need to have Python installed on your machine. If you haven't yet, visit python.org and download the latest version. Next, you'll need to install Scikit-learn using pip, which is as simple as running pip install Scikit-learn in your command line or terminal. Additionally, I recommend using a Jupyter notebook for this tutorial as it allows for interactive data analysis and visualization. Ensure you have other necessary packages like NumPy and matplotlib installed, which can be done through pip as well. Remember that compatibility is key, so make sure all your packages are up to date and compatible with each other.
Now that your environment is ready, the next step is to load and pre-process your data. For PCA to work effectively, your data needs to be clean and well prepared. Start by loading your dataset using pandas, which offers functions like read_CSV for reading data files. Once loaded, inspect your data for any missing values and decide on an appropriate strategy to handle them, such as imputation or removal. Next, it's vital to scale your features, as PCA is sensitive to the variances in your dataset. Use Scikit-learn Standard Scaler to standardize your features to have a mean of 0 and a standard deviation of 1. Lastly, ensure your data is normalized, which helps in making PCA work more efficiently by ensuring all features contribute equally to the analysis.
With your data pre-processed, we can now implement PCA. First, import PCA from the decomposition module in Scikit-learn. Initialize the PCA object by specifying the number of components you want to retain. For example, PCA n_components equals 2 will reduce your dataset to 2 dimensions. Next, fit the PCA model to your standardized data using the fit method. This step computes the principal components and the explained variance. Use the transform method to apply the dimensionality reduction on your dataset. After transforming your data, you now have a reduced dataset that retains the most important variance. Check the results by inspecting the principal components and ensuring that the transformation aligns with your expectations and objectives.
After implementing PCA, it's crucial to interpret the results correctly. A key concept here is the explained variance, which tells you how much information, or variance, is retained by each principal component. The explained_variance_ratio_ attribute of the PCA object provides the percentage of variance explained by each of the selected components. This is important because it helps you understand how well your reduced dataset represents the original data. You can also calculate the cumulative explained variance to see how many components are needed to capture a sufficient amount of variance. Analyzing these insights allows you to make informed decisions regarding the number of components to retain, balancing between dimensionality reduction and information preservation.
Determining the optimal number of components is a critical step in PCA. One common method is the elbow method, where you plot the cumulative explained variance against the number of components and look for an elbow point where adding more components yields diminishing returns. Another approach is to use a scree plot, which displays the eigenvalues associated with each component. The goal is to retain enough components to explain a high percentage of variance while ensuring the model remains efficient. By balancing dimensionality reduction with variance retention, you can optimize your PCA application, creating a model that is both robust and interpretable.
Visualizing PCA transformed data is essential for understanding the results and communicating insights. By reducing your dataset to 2 or 3 dimensions, you can create plots that highlight the relationships between different data points. Use matplotlib to create 2D or 3D scatter plots of your principal components. This visual representation helps reveal patterns, clusters, or outliers in the data that might not be obvious in the high-dimensional space. Interpreting these plots allows you to gain insights into the structure of your data, making it easier to convey complex information to stakeholders or guide further analysis. To solidify your understanding, let's apply PCA to a real-world dataset. We'll use the popular iris dataset, which is readily available in Scikit-learn. First, load the dataset and preprocess it by scaling the features. Initialize a PCA model with 2 components and fit it to the data. Transform the dataset to reduce its dimensionality while retaining the essential variance. Visualize the transformed data using a scatter plot to observe how PCA separates the different species in the dataset. Analyzing these results, you can see how PCA helps in simplifying complex datasets, making them more interpretable and suitable for further analysis or machine learning tasks.
In conclusion, we've explored the fundamentals of PCA, a powerful tool for dimensionality reduction. By implementing PCA using Scikit-learn, you can simplify complex datasets, enhance model performance, and improve interpretability. Remember that understanding and interpreting PCA results is crucial for making informed decisions in your data science projects. Continue exploring PCA by applying it to various datasets, and leverage its benefits to unlock the full potential of your data analysis. Thank you for joining this practical guide on mastering PCA with Scikit-learn.